Here we have a ICT math question. Okay, let's go the information. If the vertex of a parabola is at the point 1, 24 and the quadratic can be written as negative a times x square positive bx positive c and a, b and c are all positive integers, what is the maximum value of b? Okay, here we have the vertex for the given parabola, that is 1, 24. Since we have the vertex, let's write the quadratic function in vertex form, that is y equals to a times x negative h the whole square positive k. So this is a quadratic function vertex form. Since the leading coefficient of the given quadratic is negative a, so in the quadratic function over here, we can keep the leading coefficient as negative a. So let me take negative sign for this one. And please remember, a is a positive integer. Okay, now what I'm going to do is I'm going to plug in the vertex 1, 24 into this quadratic function vertex form. So that is h, k equals to 1, 24. That is, I have to plug in this 1 for h over here and 24 for k over here. Then I'm getting y equals to negative a times x negative 1 the whole square positive 24. Okay, now I have to expand the square of the binomial over here. To expand the square of the binomial over here, I'm going to consider the algebraic identity a negative b the whole square. So whenever I expand the square of the binomial in this form a negative b the whole square, its expansion is a square negative 2ab positive b square. So here the square of the binomial x negative 1 the whole square is exactly in the form of a negative b the whole square. At the place of a we have x, at the place of b we have 1. So in this expansion I just have to plug in x for a and 1 for b to get the expansion of the square of the binomial over here. Okay, now let me do it. Then I'm getting y equals to negative a times, so then x square negative 2ab, that is for a we have to write x, for b we have to write 1, positive b square means 1 square positive 24. Okay, then we get y equals to, we can negative a times x square, negative 2 times x times 1 will become negative 2x, positive, the 1 square becomes 1, positive 24. Now what I can do is I can distribute this negative a to this x square, negative 2, this to negative 2x and positive 1. When I do such a distribution, I'm getting negative a x square, negative times it will become positive 2ax, negative a times 1 becomes negative a, positive 24. Okay, now let me write the quadratic function over here. That is y equals to negative ax square positive 2ax negative a positive 24. Okay, now let's compare this quadratic function with the given quadratic negative ax square positive bx positive c. Let me write over here negative ax square positive bx positive c. So comparing this and this, so I'm getting negative a equals to negative a. So there is a coefficient of x square, here is negative a and here also it's negative a. And the coefficient of x in the given quadratic is b. So in our quadratic function it's 2a. So b equals to 2a. And c is the constant term in the given quadratic, and in our quadratic function the constant term is negative a positive 24. So then c equals to negative a positive 24. And the question says a, b and c are all positive integers. So that is c is a positive integer. So when c is a positive integer, it has to be greater than 0. When c is greater than 0, then the expression negative a positive 24, which is equivalent to c, also must be greater than 0. Then we get negative a positive 24 greater than 0. Okay, now to solve for a, I am adding a to both sides. When I add a to both sides, this negative a positive will cancel out. I am getting 24 greater than a. Okay, now I have to switch the stuff on the left side and right side. When I switch the stuff on the left side and right side of an inequality, I have to flip over the inequality. Then this inequality will become a less than 24. Okay, now I got the inequality for a, that is the value of a has to be less than 24. So can I consider any value less than 24 for a, like 23.5 or 23.8, 23.9, because 23.8, 23.9, all these values are less than 24. Can I consider the such values for a? No, we cannot consider all the values less than 24 for a, because the question says a is a positive integer. So any positive integer less than 24 can be considered for a. Then we can write this inequality as a less than or equal to 23. That means a can be equal to 23, or any positive integer less than 23 can be considered for a. Okay, now we got a less than or equal to 23. Okay, now what I'm going to do is I'm going to multiply both sides of this inequality by 2. Then I'm getting 2a less than or equal to 2 times 23. And here you have a question, why should I suddenly multiply both sides of the inequality by 2? There is a reason, because here b equals to 2a, that is a is multiplied by 2 over here. So I need 2a at the place over here. That's why I multiply both sides of this inequality by 2a. Then I'm getting 2a less than or equal to, when I multiply 2 times 23 is 46. Okay, now I got 2a less than or equal to 46. Already we know that b equals to 2a. Since b and 2a are equal, we can plug in this b for the 2a over here. Then I'm getting b less than or equal to 46. So b is a positive integer, and it can be equal to 46, or it can be less than 46. So the maximum value of b is 46.